Hey everybody, this is the third video for correlation, and what we're going to do with this video is take you through the 6 steps of hypothesis testing using the example of Dr. Pake's gender role flexibility in marital satisfaction study. So the research question that Dr. Pake had was, do women have more marital satisfaction if their husbands tend to be more flexible in their gender role? Okay, so the cases in this particular study were not necessarily women, they were actually couples, and from each couple they measured 2 things. They measured the woman's marital satisfaction, and that was calculated on a 0 to 4 point scale. So a 0 would be an F and a 4 would be an A, so it was kind of like a GPA rating scale. And then the male, the husband, took some sort of gender role flexibility test, and the scores ranged anywhere from 0 to 40. So a 0 meant that they were not very flexible in their gender role, and a 40 meant that they were very, very flexible. So what does a gender role flexibility test measure? Well, gender role flexibility has to do with a person's willingness to do things that are outside of the traditional scope of what defines their gender. So if you think of traditional gender roles, you know, men are the ones who are the bread earners, and they do the work around the house, you know, outside of the house. They take care of bills and lawn work and, you know, fix things and stuff like that. Women, on the other hand, you know, they may have a job. It's not as important as the husband's. Their role is more to take care of what's in the house, you know, keeping up with the housework, cleaning, laundry, cooking, kids, you know, things like that. So if a husband is more gender role flexible, it means that that person is more willing to take on the things that women typically do. Now this is kind of antiquated because we know that women and men are very flexible these days, at least more so flexible these days than they have been in the past. But anyway, you get the idea. So the question is there a relationship between marital satisfaction on the wife's part and the male's ability to be more flexible in their gender role? All right, so let's look at the data. So there were 8 couples altogether, so 8 cases, and gender role flexibility by the male, which is X. We have their values, and these are not necessarily in order. Yeah, one person was an 8, high score is 38, but what you see is that the mean score for gender role flexibility was a 25, and the standard deviation was 11.49. So for each husband, the wife's marital satisfaction was calculated, and we have anywhere from a 0.8 all the way to a 3.3, okay? And if you look at the data, it just so happens that the lowest score also correlates to the lowest gender role flexibility. The highest score in satisfaction correlates to the highest score in flexibility. Doesn't necessarily mean anything right now. So if you look at marital satisfaction, you have that range of values with a mean of 2, which would be like a C, and the standard deviation is 0.86. So we can get some information from these data, but we have to do our 6 steps of hypothesis testing, okay? So we got to pick our test, we have to check our assumptions, list our hypotheses, set our decision rule, which means what's our critical value of R, then we calculate the statistic, and then finally we interpret the results. So we know that this is a relationship test, okay? We're looking at the relationship between 2 variables, so we're going to do some sort of correlation. And so we're going to do the Pearson's R because we're looking at interval and ratio level variables for both X and Y. So what are the assumptions? Pearson's R has 4 assumptions, 3 that we've talked about before, which are random samples, independence of observation, and normality. I'm not going to bore you with those. but the new assumption is linearity. Remember that Pearson's R requires you to have a linear relationship between your variables. Otherwise, it's not going to be able to detect a relationship if one does exist. So that's a new assumption. It assumes that you're testing a linear relationship. So you have to meet that assumption. So you can do that by what? By creating a scatter plot. So here is our scatter plot. And it looks like we have a linear relationship. Okay, it's not perfect, but we tend to have this positive relationship. The higher the gender role flexibility of the husband, the higher the marital satisfaction scores. Not always the case. You know, we have this couple out here whose husband was very flexible in their role, but the wife's marital satisfaction, you know, wasn't necessarily all that high. So the point is, we use the scatter plot to test the assumption of linearity. We're good, we can continue. So now we're going to list the hypothesis. All right, so just like our difference tests that we have done in the past, relationship tests also have null and alternative hypotheses. And what we're going to do is, for the null hypothesis, instead of using mu as the population for correlation, we're going to use rho. I don't know why we do that, honestly, but that's what we do. So our null is saying that rho, the Greek letter rho, is going to equal 0, no relationship. And then h sub 1, there is going to be a relationship. And it's a non-directional test. So now we have to set our decision rule. So here's the distribution of values of R. Remember I told you that R can range anywhere from 0, where there's not a relationship at all, to 1, either positive 1 if it's a positive relationship, or minus 1 if it's a negative relationship. 1 on either side means it is a perfect relationship. So, pardon me. So this is the distribution. So how do we define what the magic number of R is that's going to determine whether we reject the null or not? Well, we are going to always do a two-tailed test because it's non-directional, and we need to decide what our alpha level is going to be, and we're going to set it to 0.05 because that's typically what we set it at, and then we have to identify our degrees of freedom. So in correlation, the degrees of freedom is always equal to the total number of cases minus 2, because for every case there are actually 2 data points. So if we have 8 cases, 8 minus 2 is 6. So 6 degrees of freedom at 0.05 with a two-tailed test. Our critical value is plus or minus 0.707. So here's our rare zone on either side of the tail. So that's our decision rule. So again, what this tells us is that if we end up calculating a statistic that is 0.707 or greater, or minus 0.707 or greater. So if our value of R falls in this rare zone, it's considered statistically rare. And what that means is that this relationship exists, and it's more likely due to it being a true relationship than it being to chance alone. So we take this critical value of R, essentially, and we're going to use it to compare to the R that we calculate. So we use our table to get all this. Okay. So the last thing I'm going to leave you with is the formula for the R statistic. And here it is. So scary, right? This is actually one of the easiest statistics to calculate. All right. We always look at this and we freak out because there's so many numbers and letters and symbols and all this good stuff. But I want you to look at this just for a second and recognize that you guys know all this stuff. What does SS mean? Sums of square. All right, you know how to do sums of square because you need to find sums of square to do a standard deviation. So you guys know this. So what this is telling you is that, you know what, you've got to find sums of square for X and sums of square for Y. Easy. Takes a little work, but you guys know this. All right, what is this telling you? Well, it's telling you in these parentheses that we have to take every value of x and subtract the mean of x. What is that? That's a deviation score, right? We've done that before too. Do the same for y. So these are operations that you have done before. So don't freak out about this. It's actually a really easy statistic to do. We're going to go through this in the next video, and you're going to find that this is so much easier than some of the statistics that we have done before. So those are the first 4 steps. We're working on the 5th step. In the next video, we'll finish this up. Again, if you've got any questions, as always, contact me at asikorsky@towmit.edu.